Hello. We are continuing with our examples. Example 4 says the moon's nearly circular orbit about the Earth has a radius of about 384. Let's draw the orbit. Let's consider this to be Earth and let's consider this to be Moon. The radius is nearly equal to 384,000 kilometers, and the period is equal to 27.3 days. That's what it says, 27.3 days. Determine the acceleration of the moon towards the Earth. Okay, yeah, this one is basically just a matter of putting in the formula that you can calculate easily. So let's do that. Let's first convert these into SI units. Our SI units, the radius has to be in meters and the period has to be in seconds. So in SI units, our radius is equal to 3.84 times 10 to the power of 8 meters. It's a matter of just multiplying this by what? By 1,000, because it's in kilometers. So by 1,000 you get what? You get your meters. So in SI units, our radius is this, and our period will be equal to 27.3 days times 24 to get the number of hours in 24.3 days times 3,600, because per every hour there is what? Per every hour there is 3,600 seconds. Here you get 2.36 times 10 to the power of 6 seconds, like that. So these are now in what? In SI units, our radius and our period. So let's use them. We know that V is going to be equal to 2 pi r over t. The distance, I'm saying V is equal to 2 pi r, and I'm putting a big T, not a small letter t, because when I'm considering a distance of 2 pi r, V, the original formula for V is equal to distance over time taken to go through that distance. But the distance that I'm considering here is 2 pi r. But that's a special type of distance, because that distance is the what? Is the circumference of the circle. It's the circumference of the circle. Then the time taken is a special type of time. It's given a special name called the period. That's why I'm just saying V is equal to 2 pi r over t, because I'm considering a special distance called the circumference, which entails also a what? A special time called period. So V is equal to 2 pi r over t. So this one will be equal to 2 pi 3.84 times 10 to the power of 8 meters over my time taken, which is 2.36 times 10 to the power of 6 seconds. These were given already. When you calculate this, you get your answer. Therefore, your A is equal to V squared over R. You know this formula by now. V squared over R, which is equal to now this one squared, which is 4 pi squared 3 times 84 times 10 to the power of 8 all over what? All over 2, because we are supposed to square this, isn't it? So it's V squared over 2.36 times 10 to the power of 6 squared multiplied by, but we need what? We need the what? The radius. There's going to be what? The radius. This one here is squared multiplied by the radius, which is 3.84 times 10 to the power of 8 squared. Yeah, I'm not simplifying, but here you could have simplified and then just put on top the answer that you'd have gotten here. You'd have put it here as answer, and maybe the answer squared over what? Over just the radius, 3.84. Not squared, no, because the radius at the bottom is just what? Is just one single r. So it's just one single r. This will cancel that. Then when you punch into your calculator, you're supposed to get an acceleration of 2.72 times 10 to the power of minus 3 meters per second squared. That is the centripetal acceleration of the moon towards the Earth due to the what? Due to the Earth's gravity. You could have also calculated this using A is equal to RW squared. But we know that our W is equal to 2 pi over what? Over period. We also know, we know that formula that says T is equal to 2 pi over W. Therefore, W is equal to 2 pi over T, right? We know that W is equal to 2 pi over T. Therefore, here we would have replaced this and said R is equal to A is equal to R W squared, which is 2 pi over T squared. and you would have just replaced with what? With the information that you are given. You're given the r, the 2 pi, you know, and the t, the period. You're given the period, put it in seconds, the radius, put it in meters, and then just punch it into your calculator. You're going to get the same acceleration, 2.72 times 10 to the power of minus 3 meters per second. So these are two very important formulae. This one and this one. Just depends on the situation which one is more applicable. All right, I think now we can what? We can. Yeah, I think it's good to just continue with the examples till the video finishes. The examples are good because they show you how to apply the principles that you're told. This one is another interesting example. It's saying, estimate the force a person must exert on a string attached to a 0.150 kg ball to make the ball revolve in a horizontal circle of radius r is equal to 0.6 meters. The ball makes 2 revolutions per second. So it makes 2 revs per second, like this. It makes 2 revolutions per second. All right, let me draw the situation that is happening here. The situation I'm going to draw from a side point of view. This is going to be the ball, and this is the center of the circle. This person is somewhere down here. This person is somewhere down here, and is revolving the ball like this in a horizontal circle. We're told that it's a horizontal circle, so it's going to be a horizontal circle. We are just picturing it from an angle like this. So the person is somewhere down here, rotating it, isn't it? So here we know that there is a ball of this mass. The radius is 0.6, and it's making 2 revolutions per second in that horizontal circle. But already in the previous examples, we now know how to convert this this period into these revolutions per second into period. One revolution is 2 revolutions are taking what? Okay, let me say that again. The period is equal to time taken for 1 revolution. That's what we know. That's the definition of period. Time taken for 1 revolution. But 2 revolutions are taking a second. Therefore, 1 revolution, what is it supposed to take? Direct proportion. It's supposed to take what? 0.5 seconds. It's supposed to take 0.5 seconds. So now we have our period. Well and fine. Now that we have our period, we want to calculate force. We want to calculate force, isn't it? We know our formula of F is equal to mv squared over r. F is equal to mrw squared. These are the most important. The other one, F is equal to mvw, is just you rarely use this one. You mainly use these two. These two are very, very important. This one you can just keep it in your head, but you can deduce it from any of these two. So these ones are very important. So mv squared over r or mrw squared. So let's calculate. From Newton, we know from Newton's second law, these are coming from what? From Newton's second law of motion. So using this first one, we need to calculate v. And we know that our v is going to be equal to distance. We know that v is equal to distance over time taken, right? But let's get a special distance. We're going to get the distance, because now we have a period. And what is the distance for the period? The distance for the period is the circumference, which is given by 2 pi r over t. This is equal to, v is equal to 2 pi r over t. This we can now calculate 2 pi r, which is 2 pi. R is 0.6 because we're told it's 0.6 over time, the period, which is 0.5. 0.6 and the period 0.5. So this will be equal to 7.54 meters per second, isn't it? 7.54 meters per second. Therefore, now we can calculate our F. Our F is equal to mv squared over r, which is just equal to m. We are told it's 0.150 kgs, and it has to be in kgs. If it was in grams, we are going to convert it into kgs because what? That is the scientific notation. So this one is 0.15 kgs, 0.15 kgs multiplied by the v squared all over the radius 0.6. So this one 0.6. The answer that you get here is going to be your force. That can be homework. You can just punch that into a calculator and you get your newtons. The answer that you get there will be your force, and it has to be what? It has to be in newtons. Easy as that. Or you could have used F is equal to mrw squared. But we know that t is equal to 2 pi over w, therefore w is equal to 2 pi over t, right? It's equal to 2 pi over t. So we can just replace this w here by what we have here. So this is equal to mr 2 pi over t squared, just like that. And now it's a matter of putting what we know. We know the mass, we know the radius, and the period. So it's just a matter of putting that into a calculator, and we get our force in newtons. So to me that was an interesting example, because now we're calculating force. We're not just calculating anything like velocity, or not like we're not ending at calculating velocity. We're taking it a step further to calculate the force, and we then use the what, our two important formulae. So these formulae are very important. I put boxes in them when we're discussing the theory section of what, of circular motion, Now let's just get into another interesting one. This, okay, I always say all of them I'm noticing now I'm saying all of them are interesting, but this one, I promise you, this one is the most interesting section. This is the most interesting example, because it is called a vertical circle. This can be a section on its own, a vertical circle. It's totally different from what we already know. Vertical circle. So let's see. Okay, let me do this in the next video, because I want it to be a section. I want it to be a section of a video on its own. So stay tuned for that video.